Number 1, write an equation of the trigonometric function graph below. Describe its amplitude, midline, and period. So we've got a trig function here, and I see that its minimum is 2, its maximum is 8, and it takes 30 units to get through one full cycle. So the period is 30. It takes 30 seconds, minutes, I don't know what it is, 30 to get through one full cycle. What's in the middle of 2 and 8? Well, I need to go what's in the middle of 2 and 8. Well, that's 6 apart, so if I cut that in half, that's 3. So if I go down 3, that gets me to my middle. So my midline is y equals 5. So, using all this information here, I can now write an equation. The period is 3, the midline is y equals 5, and we saw that the amplitude, how far up and down do I have to go? I have to go up 3 and down 3. So, is this a sine or cosine curve? So if I go to the y-axis here, I'm starting down low. So that tells me it's definitely a cosine curve. Y equals the cosine of something x plus 5. That's where we're at right now. I know there's a 3 out front because that's my amplitude. But notice that it's a cosine curve that goes upside down. It's a big hill. It's not a big valley like cosine normally is, so I need to reflect it with a negative out front. It's a negative cosine curve. And I need to figure out what to do with the period. Do I put a 30 here? No. The frequency times the period equals 2 pi. So b equals 2 pi over 30, which is pi over 15. That's the number that goes here, pi over 15, if I can leave myself any room. Pi over 15 is the frequency. That's the number that goes in my equation. So negative 3 cosine of pi over 15x plus 5. That's the equation here for this trig function. Well, graphing the function f of theta equals negative 2.5 cosine of 3 times theta plus pi, Julie stated the function had an amplitude of negative 2.5, a period of 3, and was shifted pi units to the right from cosine. Explain Julie's 3 common mistakes. Well, there's 3 definitely really common mistakes. The amplitude is just 2.5. It is always a positive number. You can't, that's just telling me I have a negative cosine curve. My amplitude is just that number there of 2.5. So the amplitude is 2.5, it's always positive. It's a distance that we're measuring, and distances are always positive. It doesn't have a period of 3, the frequency is 3. That's the number in front of our variable. The frequency is 3, so the period is 3 times p gives me 2 pi, which implies that p equals 2 pi over 3. The period is 2 pi over 3 here, not 3. The number we see in the equation is the frequency, not the period. And then we've got a little phase shift here of shifting pi units to the right. Well, notice that this is inside the trig function, so it's a horizontal shift. It's not my midline, it's a horizontal shift. But remember, inside shifts are opposite. That's not going right pi. We're shifting left pi. That inside shift is opposite. That's an opposite horizontal shift there. Not plus pi, we're actually going minus pi. It's actually a shift of minus pi, or pi to the left. So those are the 3 common mistakes that Julie made there. Don't make them. Don't make those mistakes. Graph the following functions below for the given number of cycles. Be sure to state the amplitude, period, and midline. So I have f of x equals 4 sine of 3x minus 2. Well, we always start with our home base of our midline. My midline here is y equals negative 2. Just dot that in there. There's my midline. That's the line I'm going to be oscillating around. From there, I'm going up 4 and down 4. So negative 2, negative 3, negative 4, negative 5, negative 6. Well, my frequency is 3, and I'm graphing a sine curve. So sine goes midline, max, midline, midline. There's one cycle. Well, how long did that take me is the question, and it's not 3. It's 3 times the period equals 2 pi. So the period here is pi over 3. 2 pi over 3. So that x value here, that's 2 pi over 3. And I want 3 cycles of this, so let me do it again. Maximum, middle, min, midline. Well, I need another cycle, so I'm going to go backwards this time. Sine is normally, should be able to sketch a sine curve really quickly. Sine is normally little hill, little valley, so I'm going to work backwards from here. And I'm going to go down, midline, max, middle. So working backwards, there's my third cycle, and I only want 3 cycles. Don't keep going on. I just want 3 cycles. And notice how I labeled that where that one cycle, that first cycle ends. Let me just state the amp is 4, because I'll just be complete here. The period is 2 pi over 3. G of x equals negative cosine of pi over 4x plus 5. Graph one cycle of this. So my midline is at y equals 5. 1, 2, 3, 4, 5. Here's my midline. From there, my amplitude is 1. I didn't alter that, so I'm going up to 6 and down to 4. I'm drawing, well, this is cosine is normally a valley, so I need to reflect that to graph a negative cosine, so that's going to be a big hill. The frequency is pi over 4 times the period equals 2 pi. So times 4, pi times p equals 8 pi. So my period is 8 units long. The period of this cosine curve here is 8 units long. So you have 2 options here, and I'll show you both of them. The first option is to just graph the 4 points like we always do. Min, middle, max, mid. Graph that cosine curve there. And say how many units did it take? It took 8 units to get there. That's probably the best option to do. Or since 8 is actually a nice number, you could have went and plotted all the way to 8, but I think this is much easier to say that x value there that you see is now the number 8.